All right, guys, I wanted to talk about special right triangles again and what the relationships are. We did this yesterday in class, but I wanted to give you some more examples and more, maybe something to refer back to with this video. So I want to talk about the relationship between the right triangles and kind of how we can use this idea to find different sides if we know certain things about the right triangle. And so there's two types. There's a 30, 60, 90 triangle, and there is a 45, 45, 90 triangle. And what that means is that there's a 90 degree angle, a 30 degree angle, which is here, and a 60 degree angle, which is here. When you have these three angles inside a right triangle, there's different things that we can know about it. And the 45, 45, 90, this is a 45 degree angle. This other one's a 45 degree angle, and the right angle is a 45 degree angle. And there's certain things we know about a 45, 45, 90. So, for instance, if I know that the shorter side, right, there's a long side and a short side of a right triangle of a 30, 60, 90. This is the short, and this is the long side, okay? If the short side is 4, that means the long side is 4 square root 3. All right? And if the short side is 4, that means the hypotenuse is 8. And so in general, what we say is the short side is x, the hypotenuse is 2x, and the long side is x square root 3. And this is the relationship inside a 30, 60, 90 triangle and the side lengths. So we don't have to use sine, cosine, or tangent. We could actually use this pattern that we have here to find missing sides of a 30, 60, 90 triangle. Okay, for the 45, 45, 90, if, first of all, the two sides of a 45, 45, 90 triangle are both the same. So if this side is 5, this side is 5. And then if we look at the hypotenuse, it would be 5 square root 2. All right, so in general, this is what we'd say. If this side is x, or some number, then this side should match exactly the same as that one. And the hypotenuse is going to be x times the square root of 2. And so again, we can use this idea to find missing sides of a 45, 45, 90 triangle without having to use sine, cosine, and tangent. Okay, so with that being said, let's look at a problem that we might use to use this information to solve for a right triangle. So first of all, here's the triangle we're given. I pulled this one straight from Khan Academy. And so what we want to do is we want to find this value right here. Okay, I'm actually going to give this a different variable. I'm going to give this a y variable. Okay, so we're trying to find out what y is. Y is the long side. This one is the short side, and this one is the hypotenuse. Okay, what I want to do is I want to set up two different equations. One that involves y, and one that involves the side length they've given us, this 12 square root 3. We already know what this side length is, and it corresponds to this side length on the triangle that we have the pattern for. All right, so we're going to set up that equation. What we're trying to do is we're trying to find x. We want to know what is this value right here. What is that value right there, okay? So we're going to set up that equation. So 2x, the side over here, 2x corresponds to 12 square root 3. So we're going to set that one up, because they're both the hypotenuse of their respective triangles. Okay? And I'm also going to set up an equation for y. Y corresponds to, let's pick green. Y corresponds to this side, and it also corresponds to this side. Okay, so those two are both the long side of the right triangle. Let's set that equation up. Y is equal to x times the square root of 3. Okay. Now, all I need to do is I need to figure out what is x. What is that x value? And then I can plug it into here, multiply it by the square root of 3, and have my answer. Okay. But over here, we don't know what x is because we know what 2x is. So we're just going to divide both sides by 2. and we'll get x equals 6 times the square root of 3. Now we have what x is. We can now substitute that into here to find out what y is. So y is equal to x, which is 6 square root 3, times the square root of 3. Okay, so now I'm just going to kind of simplify this, multiply the two numbers underneath the square root, and we're going to get 9. And then we'll get y equals 6 times the square root of 9 is 3, and that would give me 18. So I know that y is equal to 18, and that's what this would give us right here. We now have the y value. Okay. All right, so let's take a look at the next problem. Again, we have a 30, 60, 90 triangle, and I want to figure out where do the sides correspond to. This is the short side of this 30, 60, 90, and it's going to correspond to this short side of the 30, 60, 90. So let's set that up. X is equal to 6 square root 2. And then we're also going to figure out the side we're looking for. Again, I want to change that to y. I forgot about that. Let me do that real quick. That's y. And we want to know which side of this y corresponds to the side on the one that tells us the relationship between the sides. Okay, so that tells me that y is going to be equal to x square root of 3. So y equals x square root 3. Well, unlike the previous problem, we now know what x is. We now know that this can get substituted into that x right there. So here's what we're going to do. We're going to go y equals, and then we're going to replace that x with 6 square root 2 times the square root of 3. Okay? And then we're just going to multiply those two things together. So we can multiply the two numbers underneath the square root to make 6 square root 6. I cannot simplify this any further, so y has a value of 6 square root 6. And that would give me my answer. All right, let's take a look at the next one. So before I start this problem, I would recommend that you have this in front of you when you are doing the con practice for this particular con practice. Have this relationship there for you so you have it to refer to when you are doing these types of problems, so that you can kind of know which side corresponds to which and how to set up each of these problems. Okay? So I'm just going to color code these again like I did before. So we'll go this green one right here corresponds to this black one, or that green one there. And then we also have this short side corresponds to this short side. And so that's how we would set up our two equations, okay? So we would go like this. The two red sides we're going to set up as an equation and set them equal to each other. Okay, so x in this particular triangle is equal to 8. And then if we look at the other one, it's going to be y is equal to 2x. Okay, now this one's a little bit easier because we didn't really have much to do here. We know x is equal to 8. X is there. We're now going to take that 8, put it right here for the x, and we're going to go y is equal to 2 times 8. Y is equal to 16. And that's our answer for the third problem. All right, now for the last problem, we're going to look at a 45, 45, 90 triangle. The majority of the con practice problems that I've done are dealing with a 30, 60, 90. Just like I said before you go in to do this Khan Academy practice, I'd have that somewhere close to you, so when you run into a 45, 45, 90, you can know the relationship between all three sides. Okay? So again, I'm going to color code these like I've been doing. I only need to do 2 of these, though, because I actually don't need the fact that that's a 3. I don't need that information. Okay? Excuse me. But I do need to know that the hypotenuse right here is y, and then it's x square root 2 for that one. So I'm going to set up my 2 equations. We'll go with y corresponds to the side x square root 2. and the x corresponds to 3. So we know that x is equal to 3. And so we take this 3, we're going to substitute it into here, and we're going to get y is equal to 3 square root 2, and that's as simple as it can get. Anyway, I hope this helped, but remember, please have this at the ready when you take this common practice, and also have this one at the ready when you take the common practice. Those should help you out a lot as you move forward. So good luck. This one's going to be a tough one, I think, but if you have any questions, let me know.